This represents one of the multiple random forest regressor models trained by the multi-output regressor. Remember, multi-output regressor creates a separate regressor for each target variable. This specific instance is responsible for predicting one of the target variables, yn, in the table. These are the output values generated by the multiple random forest regressor models. Each random forest regressor produces a set of predictions corresponding to its designated target variable. The input features are the variables used to predict the target variables. Think of them as the information we have to work with. For example, if we're predicting house prices, target, the input features might include square footage, location, number of bedrooms, etc. Target variable 1 represents one of the multiple things we're trying to predict. In our house price example, this could be the actual price of a particular house. Random forest regressor 2 is one of the individual machine learning models used within the multi-output regressor. Each model focuses on predicting a single target variable. In this case, this specific random forest regressor predicts target variable 2. Remember, random forest regressor is a type of algorithm. Predictions are the output of the entire multi-output regressor process. We get multiple predictions, one for each target variable, after feeding the input features to all the individual random forest regressors. This section introduces the core problem. We're using scikit-learn's MultioutputRegressor, a tool for predicting multiple things at once, with the randomforestregressor, a type of prediction model, to see what we can predict based on given information. The goal is to understand how MultioutputRegressor works and whether the predictions it makes are independent or connected. Think of it like this. We're trying to predict multiple things at once, and we want to know if the predictions are affected by each other. Option A suggests the model makes its guesses for each thing we're trying to predict completely separately, without considering any relationship between them. This is like guessing the weather in each city without checking the weather patterns that connect them. Is this how the model actually works, or does it consider how the different predictions might relate? Option C states that the model actually builds a separate prediction model for each individual prediction. Imagine having separate weather prediction models for each city. Each model is trained independently, but they are all part of the bigger picture, the MultioutputRegressor. Does this sound accurate, or does the model use just one model for all predictions? Option D suggests that if the factors used for predictions are all strongly related, the predictions themselves will also always be perfectly in sync. However, as we've established in the previous options, the model actually trains different prediction models separately. So, even if the input is strongly related, the outputs may or may not be perfectly related. Is it really guaranteed that all predictions will be perfectly related if the input information is related? These are the independent variables used to predict the target variables. Think of them as the characteristics, or attributes, of the data points, the things we know about them. For example, if we were predicting house prices, this could include things like the size of the house, the number of bedrooms, and the location. This is the data that the model will use to make its predictions. This refers to the overall structure of the multi-output regressor model in scikit-learn. The key here is that it doesn't use a single model to predict all target variables. Instead, it trains separate models, one for each target variable. That is, if we have 3 target variables, the multi-output regressor will train 3 separate models. Since multi-output regressor trains a separate model for each target variable, this refers to the first of those models. It's a random forest regressor, a type of machine learning model used for regression tasks, predicting continuous values. It will learn the relationship between the input features, x, and the first target variable, y1. This represents the second random forest regressor model in the multi-output regressor . It's also used for regression, and it will learn the relationship between the input features, x, and the second target variable, y2. Crucially, this model operates independently of the first random forest regressor. This is the nth model. This represents a model for any number of target variables. Each model is a random forest regressor and is trained to predict its assigned target variable. These models operate independently. It's the generalization of the first two for a situation where you have n target variables, rather than just two. This is one of the dependent variables you want to predict. It's separate from the first target, y1, and represents another value you aim to forecast, using the same input features, x. In the house price example, this could be, for example, the property tax associated with the house. This represents the nth target variable. It shows that the process of having separate random forest regressors extends to any number of target variables. The model will have a separate regressor for each. For example, it could include an additional value that we may aim to forecast, based on the same input features. This is one of the variables you want the model to predict. In the house price example, it might represent the actual price of the house. The model will use the input features, x, to try and predict this value. This is our quiz question. It tests your understanding of how the multioutputRegressor in scikit-learn works, specifically when multiple target variables are involved, and how it uses the randomforestregressor. Option A suggests that each target variable is predicted separately, without considering how they might relate to each other. Is that how the multioutputRegressor actually works? Option B proposes that a single randomforestregressor handles all predictions at once. Let's see if this aligns with the multioutputRegressor's behavior. Option C suggests that a separate randomforestregressor is trained for each target variable. This is a key point to understand the multioutputRegressor's internal mechanism. Option D explores the relationship between input feature correlation and prediction correlation. Will highly correlated inputs necessarily lead to perfectly correlated predictions when using the multioutputRegressor? These are the independent variables used to predict the target variables. Think of them as the predictor variables, or the information we have to make a prediction. For example, in a real estate prediction, this could include square footage, number of bedrooms, location, etc. This is the first dependent variable we're trying to predict. In the real estate example, this could be the house price. The multi-output regressor will train a separate model to predict this variable. This is the second dependent variable. Continuing the real estate example, this could be the property tax. Again, a separate model will be trained for this variable. This represents the nth dependent variable. We might have many dependent variables to predict, and each will have its own separate model trained for it. For instance, we could also predict the number of days on the market as another target variable. This is the type of model used to predict each target variable. Scikit-learn's random forest regressor is a powerful machine learning algorithm that builds multiple decision trees to create a robust prediction model. Because multi-output regressor trains a separate model for each target variable, another random forest regressor is trained for the second target variable. And finally, a separate random forest regressor is trained for the nth target variable. Each of these regressors operates independently.